All right, today's topic, we're going to be talking about mechanical waves. And you may remember this from our last section that when we talked about a mechanical waves are waves that propagate and require a medium to do so. Here in the corner, you see I've given you a diagram of a mechanical wave. You've seen this before. And within mechanical waves, there's one mechanical wave that I specifically want to talk about in this topic, and that is going to be sound waves. Sound waves are a quintessential mechanical wave example, and most of this W3 section is going to be focused on sound waves. So let's talk about what sound is. Sound is a disturbance in matter that propagates away from its source. So basically any wave, any physical wave that moves through matter is referred to as sound. I want to differentiate the difference between sound and hearing. Hearing is the observation of the mechanical wave. So sound is the wave itself that travels, and when we hear something, we're just observing a mechanical wave in our environment. So all mechanical waves would be technically sound, yet you cannot hear every mechanical wave because not every mechanical wave will touch your eardrum. Those are the difference between them. When we talk about sound, I have a graphic right at the bottom of the screen here. You also see this in your notes. Sound is a longitudinal wave. When we did longitudinal waves in the class, we saw that the waves were on the slinky kind of bunched up the springs and expanded out the springs. When you talk about a sound wave, it's also a longitudinal wave, but we're not bunching up a spring. We're actually bunching up air molecules that we hear. So if you had a speaker like you see here that was beating the air, pushing the air, and pulling back on the air, the oscillations of the speaker push and pull back on the air around it, causing compressed areas of it. And you see this with the dark sort of vertical lines here of the particles. And then rarefacting air, and you can see that with the sparsed out particles in between. Those are the things that approach us and hit our eardrum that allow us to hear sound. This diagram is a diagram, and you see this in your notes. It's a diagram of your ear canal leading to your eardrum and all the different nerve endings that allow us to hear. Right after this, there's a quick video I want you to watch that's going to help explain how sound impacts the eardrum. It comes in through the ear canal, hits the air, and then the rest is done by our body.